तो is paramagnetic while NiCN4 2 negative is diamagnetic. ये एक्सप्लेन करना है, ठीक है ना। तो इसको अगर आप करोगे तो फर्स्ट केस में आपको होता है Cr थ्री प्लस में व्हाट इज द ऑक्सीडेशन नंबर ऑफ क्रोमियम। क्रोमियम का ऑक्सीडेशन नंबर क्या है, बोलो। यस बेटा, व्हाट इज द ऑक्सीडेशन नंबर ऑफ क्रोमियम। क्रोमियम का ऑक्सीडेशन नंबर क्या है, बोलो। Very good. It is +3, right? Because ammonia is neutral. So chromium take it as X. X plus 6 into 0 equal to +3. So oxidation number of chromium is +3, right? And what is the electronic configuration of chromium? क्रोमियम का इलेक्ट्रॉनिक कॉन्फ़िगरेशन जो है, you can say loudly, it is 4s1 3d5, ठीक है ना, 4s1 3d5. Now when it is in +3 oxidation state, so electronic configuration of chromium 3 plus, it is 3d3. Why? Because electron first removed from 4s and then from 3d. First electron is removed from higher shell number, ठीक है ना. So 4s1 it is removed, then it is 2 electrons are removed from 3d. So it is 4s1 3d5 change into 3d3. So just write the electronic configuration of our chromium. It is 3d 3, 4s and 4p are vacant, right? Now you know it is T2G3 and EG0. Okay, so no pairing takes place. So these 3 electron remains unpaired, and now we have 2d 1s, sorry, it is s, right, 4s, and 3p. So it undergoes D2 sp3 hybridization, and 6 ammonia gets attached to these orbitals, and ammonia is a ligand that will provide pair of electron to these vacant D2 sp3 hybrid orbitals. So as it has 3 unpaired electrons, therefore as it has 3 unpaired electrons, so CrNH3 plus is paramagnetic, as this complex has three unpaired electrons. So it is paramagnetic. And paramagnetic means which has unpaired electron and are weakly attracted by the magnetic field. Right? Now come to the second part. NiCN4 negative is diamagnetic. So now you know in NiCN4 negative, tell me what is the oxidation number of nickel here? What is the oxidation number of nickel in this case? What is the oxidation number of nickel in NiCN4 negative? Yes, beta. Fast. Oxidation number of nickel in NiCN4 negative. What is the oxidation number of nickel? Yes, it is +2, right? So as it is +2, wait, I think okay. So nickel has +2 oxidation number, right? Because in this case, nickel X cyanide -1. So X minus 4 equal to -2. That implies X is +2. So what is the electronic configuration of nickel? You know, electronic configuration of nickel is 3d8 4s2. Okay, so in nickel 2 plus it is 3d8. So just write it. So it is 3d8 4s and 4p. Right? Now as cyanide, tell me what about cyanide? Cyanide is a strong ligand or weak ligand? Yes, beta. Cyanide, is it strong or weak? Cyanide, is it strong ligand or weak ligand? Fast. Cyanide, is it strong ligand or weak ligand? Yes, it is a strong ligand. As it is a strong ligand, therefore pairing takes place. So three electrons are already paired. means 6 electrons are paired. So 2 electrons that get paired, and therefore it is this D 3D is left with one unpaired, but with one vacant orbital, and that's why in NiCN4 2 negative it will undergo DsP2 hybridation. Yes, very good. It is a strong ligand, and therefore it undergoes DsP2 hybridation, and they overlap with cyanide. So cyanide will give pair of electron to these orbitals, and that's why it is, yes, you can write the shape as well. It is square planar. As all the electrons are paired, so as all the electrons are paired, so this NiCN4 2 negative is diamagnetic. It is diamagnetic. Okay, is it clear to you? Any doubt in this question? See, first we have done this part, that CrNH3 3 plus has 3 unpaired electrons. That's why it is diamagnetic. Sorry, it is paramagnetic, weakly attracted by the magnetic field, and this complex is diamagnetic because it has no unpaired electron. All the electrons are paired. That's it. So this is question number, this was the question number 19. Yes, 9.19. Okay. So let's solve next question. Now next question is, okay, a solution of NiH2O6 2 plus is green, but a solution of NiCN4 2 negative is colorless. So explain. Okay, so start this question. First, in NiH2O6 2 plus, you know, in NiH2O6 2 plus, nickel is 2 plus, nickel is in plus 2 oxidation state. So it is 3D8 First write the electronic configuration of nickel. It is 3d8 4s2, right? So in NiH2O6 2 plus, nickel is in +2 state, therefore it is 3d8. Now tell me, water, is it weak ligand or strong ligand? What about water? Strong ligand or weak ligand? वाटर स्ट्रॉन्ग लिगेंड है या वीक लिगेंड है? बोलो फास्ट. H2 is a weak ligand. How do we know? From the spectrochemical series. Okay, so as H2 is a weak ligand, delta O is less than P. Delta O, very good, delta O is less than P. So pairing does not take place. Pairing does not take place. So as pairing does not take place, it means when it's 3D, 4S and 4P. So these two electrons remains as such, and that's why to use 6 vacant orbitals, 1s, 3p and 2d orbitals, outer orbital d orbitals are used, and therefore it forms outer orbital complex or high spin complex, and then water gets attached NiH2O6. So in NiH2O6 2 plus, it has 2 unpaired electrons. So as it has 2 unpaired electrons in d orbital, dd transition is possible. dd transition is possible, so it is colored. So when d orbital is 0 or d10, then there is no dd transition, and that then it is a colorless. So you know, we have done just before this question that NiCN4 2 negative, in NiCN4 2 negative there is no unpaired electron. All the electrons are paired. All the electrons are paired. Who is this? Fact teach. Namaste beta. So it is undergoing DsP2 hybridization that we have done just now. So as there is no unpaired electron in NiCN42 negative, that's why no DD transition. There is no DD transition. Why? Because it has no unpaired electron in d orbital. So it is colorless because no DD transition is possible in this case. Okay, so this is question number 20. Any doubt in it? If you have, you can ask. Yes, beta. कोई doubt नहीं है? Then we will proceed to the next question. Okay, next. Okay. Question is FeCN6 4 negative and FeH2O6 2 positive are of different colors in dilute solutions. So see, in FeCN6 4 negative or FeH2O6 2 plus, you know, cyanide is strong ligand. Cyanide is the strong ligand. And what about water? Water is the weak ligand. Close the door. Okay, cyanide is a strong ligand and water is a weak ligand. Or in both cases, what is the oxidation number of iron? What is the oxidation number of iron in both the cases? In first case, see, if we take it as X, it is -1. Here it is X, it is 0. So X minus 6 equal to -4. First case mein. So X is +2. In second case, X plus 0 equal to +2. So X is plus, means in both the cases oxidation number of iron is +2. And what is electronic configuration of iron? Electronic configuration of iron is 3d6 4s2, 3d6 4s2. So in Fe2 plus electronic configuration is 3d6. Yes, Mehul G Prajapati ji, it is available as such live now. Okay, so Fe, it is D6, right? 1, 2, 3, 4, 5, 6. Now tell me, in water, when splitting takes place, if splitting is delta O1 in case of water, okay? So in case of cyanide, you know, splitting is, let us say this delta O1, okay? And delta O2, this is in case of cyanide. Why I write them in different way? Could you figure out? Yes, beta. Thank you, beta. Vandana Ramesh. Just tell me, why I write them in such a way? In case of water, I see the gap between T2G and EG. Gap, I kept it small. And in case of cyanide, I kept this gap between T2G and EG large. Is there a specific reason? Yes, because cyanide is a strong ligand, so splitting is more, and water is a weak ligand, so splitting is less. So energy difference between T2G and EG is different, and at the same time, in case of cyanide, delta O is greater than P. Difference is more than the pairing energy. So in this case, pairing takes place. And in water, as delta O is less, so delta O is less than pairing energy, so pairing does not take place. Electrons are as that in case of free metal ion. Okay, so this form high spin complex, it will form low spin complex, inner orbital complex, outer orbital complex. Okay, so this is all about the CFT, but question is why they give different colors? Because they absorb different quanta of energy in the visible region. That's why they give different colors. CrCN6 4 नेगेटिव में कैसे हाइब्रिडाइजेशन होगा, प्लीज एक्सप्लेन इट. ओके, श्योर. तो इन विजिबल रीजन, so they are of different colors because they are absorbed light absorbed is different, so their transmitted light is also different, therefore they appear of the different colors. Simple. Okay, now question is, we have Cr NH3 6 4 negative. I think it is Cr is not in the +2 state, but anyhow if you have written it CrCN, okay, I will take it as such. So first I write the oxidation number. The oxidation number of chromium here is, it is +2, right? So electronic configuration of chromium is, you know, it is 3d5 4s1. So in chromium 2 plus it is 3d4. Okay, so now as chromium is it is 3d4, and T2G Eg, and delta O is greater than P, so pairing takes place. It is like this. So obviously chromium 3 plus in the presence of cyanide pairing takes place. Sorry. So it undergoes D2sp3 hybridization, because cyanide ions donate electron pair to each of the vacant D2sp3 hybrid orbitals of chromium 3 plus, chromium 2 plus, and it is tetrahedral in shape. Yes, Mehul. Right? So it is D2sp3 hybridized. It forms inner orbital complex, or we can say low spin complex or spin paired complex. As per valence bond theory. Okay, and the concept of strong and weak ligand, that is as per CFT, crystal field theory. So that's all for the day. Thank you so much to all of you. Have a great day. Bye bye. Good night.